Okay, so I have changed the configuration. I added a positive charge, electrostatic charge to the non-conductive end, the insulator end, and then a negative charge to the, we'll call it a conductive, capacitive type end. I mixed up the T a little bit, and I've shortened the length of the stick, and I sharpened the end. Now let's see how much faster this thing can respond to moving objects in free space. So I hear an airplane coming over, and I see the stick sort of elevating. It must have picked up on something else. Let's see here. It's turning. Just give it a second. Let it readjust. Interestingly enough, there's an oil pipe that runs underneath this house. So when I set it on the ground over here, it just spins in the direction of the oil flow through that pipe, which is pretty cool for locating oil, I guess, or water, flowing water. It would work on that as well, kind of like a divining rod. So I've adjusted the center fulcrum well, but this is moving. Here we go. So we have a pedestrian coming up. Let's see if it tracks. Yeah, so it goes right to the pedestrian and the dog. So it's pretty good for just a stick, an insulator, which is a capacitive coupling end, and a can of Pringles. And here comes a vehicle there. Oh, look at the response time is very quick. There it is. It's following, it's tracking. And it'll remember multiple objects as well. It'll go back to things that it had tracked before. I believe that's due to the memory of the water. And we'll call it the permittivity of free space. In this case, the water vapor itself remembers, and also the minerals that are dried inside the stick. The stick itself holds some moisture and some water vapor. So I'm waiting for this thing to kind of settle down here for a second. I may be in its electrostatic fill, but I believe that through electrostatic induction, this could track objects up to quite a distance. So there's the car. I'm waiting for this thing to slow down here. Last time I put a positive charge on each end. This time I got a negative charge and a positive charge, so it may be causing it to spin. I believe that's what it would do. Let me see if I can change that by adding more of a positive charge. I'm rubbing my hair, so the phone is now the source, or it's the positive end. So if my hand that's rubbing the hair is the negative source always. So the phone will act as a positive. I want to make sure I'm getting the inside of it as well as the outside, since that's how charged surfaces work. So now it's positive on both ends, and the bottle itself will become negatively charged. That way there's a strong attraction between the stick and that little pin that it's holding on right there. Now let's see what happens now. It's got very fast response time, much faster than it did before. I know the distance, the length of the stick has a lot to do with it. It really doesn't have that much to do with the straightness of the stick, because as we all know, or we're all learning through electrostatic induction, that the paths they're independent for the amount of force. So it'd be the same amount of force for the distance traveled for these charged particles. So there's a pedestrian over there. I can see him walking, and the stick is moving over toward that way. Now you see it's going left and right because both ends are positively charged, instead of having a negative on one side and a positive on the other, which would just cause it to kind of chase its own tail. And that's what's going on here. So let's see. I can hear vehicles. There's a vehicle over there. It's moving, and as the stick readies its position, it accelerates the movement of the stick to keep up with that car. It's much faster response time with the shorter stick than the longer one. And I believe that the substrate or the fluid that the stick itself and the two coupling ends, the material of the fluid has a lot to do with it as well. So, very interesting. And I can change the weight and the balance. I can counterbalance this by adding maybe another ring onto this side or a plastic ring on this end. And we'll note the differences in the effects as we go along on this series. We call this the tracker. It tracks squirrels. It'll track grasshoppers if it's sensitive enough with the right materials.